In recent years, solar panel technology has improved a lot. Now, solar energy is the fastest growing way to get power from the sun. These panels we use today actually started with space missions. When we send satellites or spaceships with people on them, we only have two options for power: solar energy or nuclear power. But of these two, only solar energy doesn't have limits, because we don't need to carry fuel with us. Now, imagine if we want to travel to other star systems. Here's the big question: can solar panels work there, close to different stars? To understand this, let's dive into how solar panels work. Solar panels make electricity using something called the photoelectric effect. This effect was first discovered a long time ago, back in the 1800s. Scientists noticed that when they shine ultraviolet light on metal, it makes the metal give off electrons. This showed that light is made up of tiny particles called photons. After this discovery, scientists started finding ways to use this effect to create electric power. The first real solar cells came about in the middle of the 1900s. Since then, scientists have been working to make solar cells better. Today, we have highly efficient solar panels that can capture not only ultraviolet light, but also visible and even infrared light. But there's a catch. Our current solar panels are designed to catch the sunlight coming from our sun. Our sun emits a lot of light in the green and ultraviolet range, which is perfect for our solar panels. But here's the challenge. Many planets outside our solar system, known as exoplanets, orbit stars called red dwarf stars. These stars shine brightest in the red or infrared light and emit very little ultraviolet light. So, if we want to visit these exoplanets in the future, like Proxima Centauri, we'll need solar panels that can capture light from red dwarf stars. Researchers have been studying how well solar panels work under different types of starlight. They're particularly interested in comparing our sun's light to the light from stars like Proxima Centauri. They've been focusing on a type of solar technology called organic photovoltaics, OPVs. These are cool because they're lightweight and flexible, which is handy for things like huge solar sails on early interstellar missions. OPVs are still quite new technology, but they have a big advantage over the older silicon-based solar cells. They can be adjusted to work with different types of light. This depends on something called the band gap, which is like a special energy zone that helps make a solar cell work well. The research showed that for sunlight, solar cells with a wider band gap work best, with a theoretical efficiency of 18.9%. But for Proxima Centauri's light, they need a narrower band gap, and the efficiency drops to 0.9%. So, solar panels could make electricity from red dwarf stars, but there's a big problem. These stars give out way less light than our sun. Even with the best solar cells, the electricity from a single cell won't be enough. To get more energy, we'd need much bigger solar panels. That means they'd be heavier and more expensive. Still, there's hope that better materials research could lead to more efficient ways of making electricity from starlight. So, while it's a challenge, it's possible that one day we might have solar panels that work near other stars. I hope you enjoyed watching this video, and if you are interested in more content like this, please consider subscribing to Explore. These videos might catch your interest. I highly suggest that you watch them.